Welcome back, everybody. Today is talking about graphs of absolute value functions. Now, the absolute value function looks like this. F of x equals absolute value of x. And it generally has like a V shape, as we can see on Desmos here. Let's go to Desmos and let's graph that. You can see it right here. I already have some functions put up. But yeah, that's the basic absolute value. See the V shape, where no matter what you plug in for x, it always outputs the absolute value of x, which will guarantee positivity for all y values. So just keep that in mind as the basic function, basic look of the graph of f of x. Now, we're going to work on transforming it. We'll also talk about finding the vertex of the absolute value function. Now, there's some things we can do to it. Here's our absolute value. So we'll put it in parentheses to prove something here. It could multiply by a constant a. A could be positive, negative, fraction, greater than 1, which we'll talk about. Minus h is going to determine a shift horizontally or vertically, and plus k is going to determine a shift vertically or vertically up or down, whereas h, like I said, h is going to be horizontal, left or right. Let's talk about a for a little bit, depending on what that number is. If a is less than 0, meaning a negative number, we're going to reflect it over the x-axis. So this basically will flip vertically, and that's if you have positive to negative, or you just put a negative in front of the function, it'll flip it upside down. If a is greater than 1, that will be a vertical stretch it vertically. It'll kind of get skinnier, so to speak. If a is less than 1, but greater than 0, that will be the opposite of stretch, compress. Makes it fatter, for lack of a better word. Smushes it down. It stretches it horizontally, makes it wider. Okay. H, well, let's talk about k first. K, if k is positive, if we have a positive k, then the graph shifts up from the original graph. If it's negative, it will shift it that many units down. Now let's talk about h. Notice how it's in parentheses right next to the x. The opposite is true. You kind of think if it's positive h, it'd go right, negative h, go left, but actually the opposite is true. Say it's a minus h, then the function will shift to the right that many. If it's a plus h, plus some number, the function's going to shift to the left. It's sort of the opposite of what you think. Something else to note. The h and k, if I have minus h and plus k, my vertex, the point where it comes to, the tip of the V, will be the hk numbers. We'll see that here in a couple examples. Hk. Now keep in mind it has to be, if it's minus h, it'll be positive here. If it's plus h, it would be minus here. Okay, so that's how you kind of identify the vertex. Kind of goes along with this opposite of what you think here, where minus h moves to the right, plus h moves to the left. We'll kind of see this pan out here in the next couple examples. All right, we're just going to identify which of these graphs represents f of x equals negative x, negative absolute value x minus 3 plus 1. Well, we can kind of identify, we'll verify it with Desmos, but think about it. We're going from the general function absolute value of x, which looks like it's just normal v. And let me make this a little more, so let me make these straight lines here. There we go. So this is just plain old absolute value of x. F of x equals the absolute value of x. But according to this, and what we just talked about the transformations, it's going to be flipped over the x-axis, so it's going to be either one of these here, where we flip it upside down. and it's shifted to the right 3 and up 1. The vertex is going to be shifted right 3 and up 1. In fact, I can identify the vertex as 3, 1, just like we said earlier, the HK. Alright, and so once we find that, okay, it's going to be one of these two. We need to go right 3 and up 1. Up, it's not this one. Right 3 and up 1, right here. We can find it right there. That one on the very far right here is the graph. And you just by transforming that and knowing what these numbers move it and how they move it, I was able to get that. But let's verify it on Desmos. Negative x is the very first one here. You can see that typed in there. +1, there we go. You can always verify on Desmos. Just plug the function in, negative x minus 3 plus 1. Notice the -3 is telling me I have a vertex at 3 right here, and the +1, that's the y coordinate. There it is, 3, 1. 3, 1. Alright, let's look at another one here. It says, what are the coordinates of the vertex of the graph of -3, absolute value of x minus 1? Alright, well, first just imagine the original function, just plain old absolute value of x. And then we've done some things to it. Well, we stretched it by a factor of 3. We flipped it over the x-axis, and apparently we shifted to the right one. But we're going to use just the HK to see where the vertex is. Okay, so we had negative, it turned into this, -3, x minus 1. Alright, so we know the h number is that 1 there. That's going to be part of the vertex. But then I don't see a k, and if you don't see a k, the number's there. Just the number that means nothing, 0. So there's our k. HK is 1, 0. 1, 0. And of course you can always verify this on Desmos. Let's go back over to Desmos real quick. Alright, here it is, the second one, -3, absolute value x minus 1. You can see that. Here's our vertex right here at 1, 0. You can verify that for sure. So you can either look at it through Desmos and see it graphically, or just know what the equation is telling you with the HK. Alright, look at another one here. What's this asking? What type of transformation takes the graph of f of x equals absolute value of x to the graph of g of x equals 2.5x? Okay, well, notice the a number here, the 2.5. It's greater than 1, and as we said on the first page, since a is greater than 1, it's stretching it vertically. We'll say it like this. F of x is stretched vertically. How much is it stretched? By a factor of 2.5. There we go. You can, of course, we can see that transformation on Desmos. Let's look. Here's the original function, and then here's 2.5 times the function. Look how it's stretched vertically. It's gotten thinner, skinnier. It's stretched vertically, and by how much? By 2.5. I guess you could say g of x is 2.5 times as skinny as h of x, f of x. Alright. Next one here. Graph of g of x is obtained by reflecting f of x equals 4 absolute value of x over the x-axis. What's the equation that would describe a g of x? Alright. Well, if f of x is 4 absolute value, and we just want to reflect it over the x-axis, we need to make that 4 a negative. -4 absolute value of x. And of course we can see this demonstrated with Desmos. Here's 4, here's the one in question, 4 absolute value of x, and then if you reflect it over the x-axis, you may put a negative in front of the 4, and you can see that reflection right there. Alright, one more here. The graph of g of x is obtained by translating f of x equals absolute value of 2x 5 units to the left. What's the equation that describes this? A little bit tricky, given that the translation is horizontal, and so it's going to involve a movement of h units, as we talked about at the beginning. Here's the original function, 2 of x, 2x absolute value. But I'm going to do g of x, and we think of the x, kind of think of x as its own little mini function, and that's the thing that gets moved, not the 2. The 2 isn't part of it. Just think of the x. That's why we put it in parentheses, 2 parentheses, and then we're going to do something with the x here and then close it out, absolute value. And if I'm going to the left, it's kind of the opposite of what I think. To the left on the x-axis have negative values, but it's the opposite. So I'm going to actually do a plus 5 here. And this tells me the original function gets shifted 5 units to the left. We can verify that on Desmos like we did the others. Here's the original function, absolute value of 2x. We have that graphed. And if I'm going to shift this 5 units to the left, this function will do it. 2 parentheses x plus 5. You can count yourself 1, 2, 3, 4, 5 units to the left. And there we are. I hope this helped with our understanding of absolute value functions and their graphs. Thank you for watching.